Kasımpaşa University from Turkey, and National Technical University Kharkiv Polytechnic Institute from Ukraine. The symposium is also technically sponsored by IEEE Turkey section. Thank you for your scientific computation and support symposium. Now let's start the session. If you want, first paper belong to dear Barah Al-Sangaray.
Yes.
Are you present?
Yes, I'm ready. Let me share my screen.
You have 10 minutes, please.
Okay. Hello, everyone. My name is Barah Al-Sangaray. I'm a master degree student at Yıldız Technical University. I will present our study under the title Performance Evaluation of Various Machine Learning Techniques Used for Software Fault Prediction using NASA dataset. So first, our outline will be introduction, and please look at the algorithms used in this work, express the data set and discussing the results, and lastly, the conclusion. The first part will talk about the most significant issues for software developers is how to create high quality software. Therefore, methods have been investigated during the software development cycle to produce a software of high standard. One of these methods is software fault prediction that helps to predict these errors that degrade the software quality. So software fault prediction used to reduce cost, time, and effort when handling the software projects. Moreover, it is used to increase the ability to reach a high dependable system, improve the test process, select the best design from a variety of design alternatives, identify refactoring candidates that are predicted to be fault-prone, and improve quality. So, for the machine learning used in this study, we have applied in software fault prediction by preparing a classifier to denote whether the software module are faulty or not. So in this study, several machine learning techniques have been used, which include logistic regression, random forest, naive-Bayes, support vector machine, k-nearest neighbor with 3 distance matrix, Minkowski, Manhattan, Hamming, and decision tree. So each of these mentioned algorithms has been a specific mechanism to deal with the training data and build the optimized model. Our data set used in this study based on a data set given by NASA named as JM1, which is a real-time predictive ground system written in C language. Each record in the data set has been labeled as shown in the table aside, and it indicates whether or not the error has been recorded. In this work, Google Colab platform has been used. Google Colab supports a large number of libraries and other ready-to-use libraries. So in this study, also data normalization has been applied by using minimum maximum feature scaling. Then 3 cases have been considered to extract the result. To extract the results, first one by using the original data after normalization. The second one by using random oversampling, and lastly is mods. So for our first case, Random forest classifier records the best overall result with 61%, and the worst performance recorded from KNN classifier with Hamming distance equal to 67.84%, while the KN classifier with Minkowski distance gives us the best result among the other distance with average accuracy of 76.71%. For the second case, which is represented by using random oversampling, the best average accuracy was achieved by random forest model with 92.28%, while subboard vector machine model achieved a minimum performance with 62.17%. The third case is SMOTS. Random forest algorithm also achieved the optimum performance with an average accuracy of 88.41%, while the worst was recorded by subboard vector machine with 62.36%. We can summarize the result of the optimal performance for random forest classifier as shown in the table aside, and illustrate the result of the classification by using the confusion matrix shown in the figure below. So our conclusion, this study addresses software fault prediction issues using NASA's 21 features JM1 dataset using machine learning algorithms. So 6 machine learning algorithms has been used. After data normalization and using three cases were examined, random forest algorithm has indicated the best performance in contrast to the other algorithms for the 3 mentioned cases with average accuracy of 81, 92, and 88% respectively. Furthermore, the using of random oversampling gives us the optimal performance compared to the other 2 methods due to its mechanism of duplicating the original samples of the miniatory classes. Thank you for your attention. If you have any question, I'm ready to answer.
Thanks for your presentation. Dear participants, do you have any questions about the study? Okay, no questions. Thank you again. I wish you success, dear Barah Sangari.
Thank you so much.
Dear Ceren Dursun.
I'm present. I can
Okay.
start.
You can start your presentation if you want. You have 10 minutes, please.
Okay, thank you. Hello, everyone. My name is Ceren Dursun, and I will present to you our study on enhancing recommendations with aspect-based sentiment in neural collaborative filtering. We have worked on this study with Alper Özcan, and I am a graduate student from Computer Engineering Department of Akdeniz University, and Associate Professor Dr. Alper Özcan is both my professor and my advisor. So I will briefly explain the problem definition and move on to recommender systems and neural collaborative filtering. In this part of the presentation, I will talk about the differences between neural collaborative filtering and collaborative filtering. And in the next chapter, I will be explaining the overall structure of our model. And lastly, I will be talking about the results and conclude my presentation. So in today's world, users are presented with a diverse range of accommodation options due to the increase in the online booking platforms. And it is making it challenging to filter the most suitable choice for their needs and preferences. Due to the increase in the alternative accommodation options, users have to examine numerous reviews to discover a hotel that aligns perfectly with their expectations, preferences, and needs. And recommendation engines could provide tailored recommendation to one's preferences and needs. Explicit information and user ratings and user reviews are crucial elements for improving the performance of recommender systems. An effective combination of explicit data, user ratings, and user reviews can enhance recommendations accuracy and address the problem of sparse data. Some recommendation algorithms focus only on user ratings and specific explicit information, but they ignore the valuable insights provided by the user reviews. So to address these limitations and drawbacks, our study proposes an innovative approach that leverages aspect-based sentiment analysis to provide broader and deeper representations of users, items, and sentiments in the latent space. So recommender systems are algorithms that analyze user preferences, behaviors, and historical data to provide personalized recommendations. These systems are widely used in various domains such as e-commerce, music, and in our case, tourism industry. And in the tourism industry, recommender systems play a crucial role in improving the overall experience of customers. It will help users to find suitable accommodations tailored to their needs and preferences. Utilization of recommender systems would improve the overall experience of customers and assist the tourism industry in both attracting and retaining customers. Moreover, recommendation systems assist in the tourism industry in attracting and retaining customers by providing tailored suggestions. However, while traditional recommender systems offer valuable recommendations, they often treat items as a whole and without considering the specific aspects that users might prioritize. For example, in the context of hotel recommendations, a traveler might value cleanliness, location, amenities, and customer service differently. And to address this challenge, aspect-based recommender systems has emerged as a more accurate approach. By considering the specific aspects that users value, aspect-based recommender systems could provide more precise and personalized recommendations. So in the realm of recommendation systems, two prominent approaches are collaborative filtering and neural collaborative filtering, and I will briefly explain how those approaches differ from one another. So collaborative filtering analyzes the behaviors and preferences of different users to identify similarities among them. And recommendations are made based on the similarities between users, and it assumes that users who have similar tastes in the past will have similar preferences in the future. So it is not really explaining the user-item relationship well, and therefore the recommendations are not as precise. However, in contrast to that, neural collaborative filtering introduces neural networks to model user-item interactions and provide personalized recommendations, as it focuses on the direct interactions between users and items rather than relying solely on the user similarities. It uses neural networks to capture complex relationships, and it improves the accuracy and relevance of recommendations compared to collaborative filtering. So this is our proposed model. And by incorporating predefined aspects of hotels and modeling sentiment scores associated with each aspect, our recommendation engine captures the nuanced preferences of users. This allows us to generate tailored recommendations that align with user-specific preferences and needs. We employ the hotel ID and user ID as our input features. The input features consisted of user elements and hotel elements, along with the related aspects and their sentiment scores. These features serve as a crucial element in our framework. And to effectively learn from the input, the embedding layer transforms the sparse representation into a dense vector. And actual ratings represent the ratings predicted from the hotel reviews of the users. And the predicted ratings are the output scores from our model. So I'm going to be explaining our data sets. In this study, we have used HotelRec dataset, which is actually one of the largest hotel review datasets online. The initial dataset were approximately 50 million hotel reviews. And all of these reviews have been extracted from just one online booking platform, which is TripAdvisor. And the data includes reviews from 2001 to 2019, and each review includes the author name, the hotel URL, the overall rating, review summary, user-generated review, the date of the review, and multiple subratings of aspects. And in order to conduct the aspect-based sentiment analysis on the user-generated reviews, we have to pre-process the data, as the user-generated reviews are just unstructured text data. So initially, we have started extracted the reviews from 2018 and 2019, as they were the most recent data available in our data set. And later on, the stop words that do not make any changes in the context of the meaning of the sentence and punctuation marks have been excluded from the user-generated reviews. The reviews are normalized with lowercase conversion. And lastly, tokenization has been performed to only include nouns and adjectives in the reviews. So we have used the predefined aspects as the HotelRec dataset includes user-generated subratings for aspects as well. And these aspects are rooms, cleanliness, service, value, location, and sleep quality. These predefined aspects hold value for users as they directly contribute to their overall satisfaction and meet their specific preferences and expectations. By incorporating these aspects and associated sentiment scores into our recommendation engine, we can offer personalized recommendation that aligns with individuals' needs and priorities. So in order to conduct our study, we have to actually identify which are the common words for each of our aspects. And it is a really crucial point in the study. For example, in the aspect service, words like friendly, professional, helpful, and hospitality were identified as aspect terms. The frequently used keywords for aspects were taken from a previous study by Akhtar and others, and they have conducted a true analysis using LDA topic modeling to identify and define the common keywords linked to each aspect from a large data set of TripAdvisor hotel reviews. So we truly analyzed the most frequent terms observed in our data set to identify the aspect words related to each aspect. And the final aspect keywords were chosen using a combined strategy of statistical analysis and manual examination to filter out irrelevant terms. And although this study has more aspects, by meaning the Akhtar's and others study, we haven't considered them in our study. So for the aspect-based sentiment analysis, we have used the Valence-Aware dictionary for sentiment reasoning, as it takes into account both the polarity, which is meaning if the sentence is positive or negative, and the strength of the sentiment. It is providing a richer grasp of sentiment valence. It has been employed in our study to evaluate the aspect-based sentiment scores for each of the aspects from pre-processed text reviews. And the polarity scores of each aspect were obtained by the sentiment intensity analyzer methods in the Vader sentiment library. And user-specific features, aspect-based sentiment scores, and hotel information made up the model's three main input components. We first normalized the polarity scores to ensure the consistency and compatibility with the model's input specifications before including aspect-based sentiment into our model. And to evaluate the performance of our model, we made an experiment actually. And in that experiment, we have used the user-generated subrating of the aspects from the initial HotelRec data. So here are the results of the experiment. According to the results, our proposed method has shown better results than the experiments where we used user-generated subratings. So based on the results of the experiment, our model sentiment enhanced based recommendation system is a more sensitive and personalized hotel recommendation system. In order to conclude, since ratings merely represent the overall satisfaction with an item, deducing the underlying logic of the rating is challenging, and as users may be interested in different aspects of an item. And our proposed model offers a solution by providing more accurate recommendations by integrating the behavioral data, mainly user ratings and reviews, which indicate the aspects of the items users are interested in. So that is all from my side. If you have any questions, I would be more than happy to answer them. Thank you for your time.
Thanks for your presentation. Dear participant, do you have any question about the study? Okay, no question. Thank you again. I wish you success, dear Ceren
Thank you so much.
Dursun. Dear Elif Nur Küçük.
I'm here.
Okay, are you present?
I did the for payment.
Okay, you can share your screen. You have 10 minutes, please.
Thank you. Dear participants and viewers, welcome. I am Elif Nur Küçük. I am research assistant at Manisa Celal Bayar University, Department of Software Engineering. In this presentation, I will explain the work we prepared with my advisor, Aybar Sur. The title of our research is Effect of Data Augmentation Techniques on Classification Performance in NeMRI. Research question, is the amount of data imported in age prediction with deep learning? The role of amount of data used in increasing the effectiveness of deep learning models is very important. Due to the insufficient publicly available data, in some subfields of health, data augmentation is vital. At this stage, it's also important to choose the ones that are compatible with the problem among the data augmentation techniques. In this study, the effects of different data augmentation techniques on classification success for near-tier classification. Task over three-dimensional MR images containing hard tissue images were examined comparatively. Introduction, deep learning applications for the task of inferring from medical image can potentially assist clinicians in decision making, treatment planning, and increasing operational efficiency based on the similarity and important commentaries in MRI data. Intelligent systems that automatically detect disorders have gained great importance in the medical field. Thanks to these systems, many advantages such as taking auxiliary role in diagnosis and diagnosis of physicians, providing pre-diagnosis and pre-treatment guidance in order to minimize the spatial time constraints experienced in hospitals can be obtained. Application of deep learning in medical image analysis is of a difficult task due to limited training data, insufficient quality of image for inference, privacy concerns, labeling costs. Obtaining well annotated medical data can be costly and time-consuming. In solving this problem, data augmentation is generally applied to increase the size diversity of the training sets in deep learning, which can be considered and regulation technique. Data augmentation is a technique that has improved the ability of deep neural networks to make accurate decision on image. It's popularly used in scenarios where the amount of data is limited. The data set is unstable and acquiring new samples is costly and time-consuming. There are many studies that produce successful analysis with the help of deep learning using medical image, and data augmentation is cases where data is insufficient. Total 18 patients, 70 different inspection images, 3 axis views for each exam, 569 females, 611 male patients, 319 ACLs, 508 meniscus, 7 of 4 abnormal tears detection. Method, data augmentation. In our study, traditional data augmentation technique, which include the most frequently used methods on MRIs, are augmented by color space transformation and auto-augment techniques. Transfer learning models. The characteristic of these age classes from the augmented dataset were extracted using the ResNet 50 Inception V3 VGG 16 models from transfer learning models. In the current study, to compare data augmentation methods over MRNet datasets using traditional data augmentation techniques and color space transformation in the IMG-AUG data augmentation library in experiment 1, using traditional data augmentation techniques in the image data generator experiment 2, and auto-augment architecture in experiment 3. 3 different experiments were carried out by using a different data augmentation method in each experiment. The classification success obtained from the raw data and augmented data were measured. The data augmentation methods used in the experiments are summarized in the table. Experiment 1. In experiment 1, some of the pixels in the image were reset by one of the arithmetic increment methods from the image data augmented to the converted image. Rectangular areas in the images were drawn by using coarse dropout. The images were sharpened with a sharpen, and the images were rotated in the range of minus 25 to plus 25 according to the coordinate plane with rotate. One of the transformed methods. HDTech is sorry. HDTech is applied to the image, detecting the age in the image, marking them as black and white, and using a random blending factor between 0 and 1. The result is blended with the original input image. It has been embossed with embossed images have been selected horizontal with flipper and cropped 25% and on all sides using crop and type and filled with black pixels. Experiment 2. In experiment 2, the middle 3 images were taken in the image sequence of each axis, and it was carried out using some data augmentation techniques within Keras image data generator class. The images were rotated 25 degrees, and gaps in the picture due to rotation were filled with the closed pixel values with fill mode. Images are shifted up and down with high shift range for vertical shift of the image and with shift range for horizontal shift of the image. A 0.3 zoom was applied to the images in the augmented image. In experiments, the pixels were scaled at 0 mean by centering and scaled to conform to the unit variance with standardization. Experiment 3. Auto-augment in experiment 3 are taken from PIL, a popular Python image library. all functions in the field that accept an image as input and still create an image are used. In addition, two other magnification techniques are used, such as cutout and sample pairing. The operations applied are shear XY, translate XY, rotate, auto contrast, invert, equalize, polarize, posterize, contrast, color, brightness, sharpness, trim, and sample mesh. The results of our study are as in the table. We will interpret the results on the next page. In the experiment performance on the original image without data augmentation, the insertion with remodel provided the highest success with 2.5% for the normal class. In the experiment performance on the images augmented by applying the augmentation techniques, experiment 1, the highest interest was in the detection of abnormal class in the ResNet 15 model, and the success increased from 81.43% to 15.23%. In the experiment performance on the images augmented by applying the augmentation mix in experiment 2, the highest increase was in detection of meniscus class in the VGG 16 model, and success improved from 56.11% to 68.61%. In the experiment performance on the images augmented by applying the augmentation techniques in the experiment 3, the highest increase was in the detection of meniscus class in the VGG 16 model, and success increased from 56.11%, 74.44%. Conclusion. As a result of studies in the literature, the intensity of augmentation studies on soft tissue, MRI draw attention. However, when it comes on and hard tissue, there is a lack of studies that increase data on MRI images. For this reason, the success of data augmentation methods on hard tissue was compared in the present study. Thus, results that will guide the data augmentation of future studies on hard tissue MRI have been obtained in all of the experiments conducted of different models. It was determined that the data augmentation technique used together with the auto-augment method is higher success than the traditional data augmentation method. It has been shown that for researchers who need use data augmentation, the use of the architecture allows more successful data augmentation in a shorter time for sensitive images such as MRI. Thanks for listening.
Thanks for your presentation. Dear participants, do you have any question about this presentation? Okay, no questions. Thank you again, dear Elif Nur Küçük. I wish you success in your career. Dear Hashin Kotegoda, are you ready to present?
Yeah, so I am Divshan Nandarvira. I am be presenting on behalf of Hashin Kotegoda today.
Okay. If you are ready, you can share your screen and then start your presentation.
Sure. So
You have 10 minutes, please.
Yeah,
You
thank
have 10 minutes. Okay.
So we are a student from Sri Lanka Institute of Information Technology. So our research is on advancing canine health and care through an multifaceted approach using machine learning. So as for the introduction, in this research, we aim to address several challenges faced by dog adopters owners providing a comprehensive solution to enhance the well-being of their beloved pets. So through innovative technologies and machine learning, our research aims to bridge these knowledge gaps, empowering dog owners with valuable insights and guide them in providing the best possible care for their canine companions. So as for our objectives, we have 4 objectives. The first one is we have addressed the lack of information that the dog adopters often face regarding their dog's breed and age. And the next one is providing a personalized dog meal plans considering the factors like breed, age, weight, health, and emotions to promote overall health and well-being for their pets. And the next one is help dog owners to comprehend the reason behind their dog's behavior changes. And lastly, we have provided a reliable and efficient system for remotely monitoring dogs when they are alone at home. So if we go to the first problem, dog breed and identification, the methodology is as follows. For this, we have used a publicly available dataset, specifically the Stanford dog dataset for breed identification and the dog age dataset from Kaggle for age identification. Our objective was to develop a mobile application that can determine the dog's age, breed, including whether it's a pure breed or a mixed breed. We employed a transfer-learning approach using Inception V3 models, and we have added additional layers for breed identification and created separate breed identification and create a separate model for age identification as well. So as for the result in dog breed and age identification, we are able to achieve an accuracy of training both age and breed classification models. The breed model achieved an 89% of accuracy, and the age model achieved an 82% of accuracy. However, the breed classification showed an challenges due to subtle differences within breeds and factors like age and gender. So these are the user interfaces of the dog breed and age identification. So moving to the next, generating a personalized nutrition plan for their dogs. In the methodology, we have focused on developing a personalized meal plan system for dogs using a rule-based system and using a reinforcement learning algorithms. We collect a data set from various sources considering factors such as breed, weight, age, activity level, and health conditions to calculate the daily nutrition requirements. And we optimize the weekly meal plan using reinforcement learning, considering factors like weight, health level, and emotional states. The system adapts to each dog's metabolism and stability levels through continuous optimization based on the user's feedback. As for the result, with an 84% of accuracy, the system was able to accurately calculate dairy nutrition requirements by considering all the factors that we have considered. Furthermore, implementing the reinforcement learning techniques improved the system performance by outperforming random approaches. So these are the user interfaces of generating personalized nutrition plans. And moving on to the dog disease identification. So in the methodology of this, the dog disease identification system is implemented using an artificial neural network approach. So we have collected a diverse dataset of dog disease and their corresponding symptoms from reliable sources. And the ANN model was trained using techniques like backpropagation and optimization, resulting in a robust and accurate decision identification system. As for the result of this dog disease identification, so model was able to achieve an accuracy of 92%, accurately identifying various dog diseases, including both common and rare diseases. So these are, of course, the dog disease identification using interfaces. And lastly, for dog sound classification using remote monitoring system. For the methodology of this, we have built a real-time dog sound classification system using a transfer learning approach. So we have utilized the YumNet pre-trained model as the base model for feature extraction. And we have used Maxkalina dog bark datasets for training and testing. So we retrained the model by adding new final layers to classify classes like normal barks, aggressive barks, growling sounds, and whining sounds or crying sounds. So for the result of dog sound classification, the dog's sound classification model was achieved an accuracy of 74% with compatibility for most of the dog breeds. So the model shown an high accuracy rate for whining and growling sound, but slightly lower accuracy for aggressive and non-aggressive barks. So the model's performance was tested on a Raspberry Pi 4 with an 2 GB of memory, and it has shown an average prediction time of 1.2 seconds. So these are the user interfaces of the sound classification. And for the conclusion, this research has successfully developed and evaluated machine learning models for dog breed and age identification, personalizing a nutrition plan using reinforcement learning, and dogs disease identification using ANN, and dog sound classification using transfer learning approaches. The models demonstrated effective and accurate in their respective areas, providing a practical solution for dog care. Although further improvements are possible through dataset expansions and progressions of different architecture and algorithms, the findings have significant potential for the real world implementation, benefiting in pet owners and veterinarians alike. So thank you. If there are any questions, I would like to address those.
Thanks for your presentation. Dear person, to have any question? Okay, thank you again. No question, I guess. I wish you success in your career. Dear Pankaj Goswami, dear Pankaj Goswami, are you online? Okay. Dear Rafsan,
yeah, I'm here. Yeah, I'm here. Am I audible?
Okay.
Yeah.
Are you ready to present?
Yeah, exactly. I'm going to share my slides.
Okay.
Just please wait.
You can share your screen.
Yeah, I'm trying it. I suppose there's some issue. I'm trying it. Can you plus do me the next because I'm just getting some issue.
Okay,
just after,
okay.
Yeah, please.
Okay.
Please.
Dear Rafsan Bali Shafin,
am I audible?
are you ready to present?
Yes.
Okay, if you are ready, you can start.
Am I audible?
Okay. Please, you have 10 minutes.
Good morning, everyone. Welcome to the presentation of paper ID 212, which is enhancing performance of extractive multi-document update summarization on tag dataset. I am Rafsan Bari Shafin, the presenter of this paper, and my other co-authors are Mara Khanum Nurtaj, MD Nahid Hassan, Kirtika Roy, and MD Saddam Hussain Khan, Rashidul Amin Tuhin, and MD Mohsin Uddin. And we are from Department of Computer Science and Engineering of East West University, Dhaka, Bangladesh. This is the overview of our presentation. We have introduction, related works, strategy suggestion, dataset, methodology, result analysis, conclusion, and finally the reference part. You may wonder what the update summarization task is. Automatic update summarization is a method that seeks to present the user with the most recent and updated information. Suppose any natural disaster like earthquake, flood, cyclone occurred. By that time, information are so unclear and hard to get actual information over time. In this case, automatic update summarization helps to get the updated information time to time. While researching for this problem, we have gone through a lot of articles and research papers and gathered knowledge to solve our problem. In one of the papers, authors studied real-time selective summarization of event type texting using TREC KBA 2014 stream corpus. In another research, author proposed an unsupervised non-parametric Bayesian model inspired by latent dialect allocation. In the last one, author used an alternative approach to the multi-document summarization system, where it used a bag of words model to enhance the efficiency. We suggest the following method to guide the future studies and experiment in order to encourage continuing improvements in the area of update summarization. There are data preparation, like preparing data, adding precise format of a document like tag dataset. There is data extraction, like extract key information from the news source. There is text preprocessing, like POS tagging, cleaning stopwords, removing numbers, removing extra white spaces, punctuation, converting into same case, recognition or name entities, lemmatization or stemming, enlarged contraction, and tokenization. Then it comes to the summarization. For generating summary, we can use Pegasus, Transformer, BART, GPT-3 model, and so on can be used. There then the summary removal, which will remove the older information from the database and replace with the new one. And finally, the evaluation and iteration using the root score. Now the dataset part. There are many types of multi-document dataset like TAC 2009, TAC 2010, TAC 2011, DOC 2004. From all of that, we have used TAC 2009 for our model, which actually give us the best output. TAC 2009 dataset contains 44 topics. Those 44 topics are divided into 2 sections and each have 10 small newses. Here you can see our model generated summary and dataset summary length respectively. And in this bar chart, we can see that dataset full text token count and summary text token count. Let's talk about the methodology part. To generate our respective summary, we have used 2 types of model, T5 transformer and TextSense plus Pegasus. The T5 transformer model first takes input from the attachment and checks within itself and from the database whether it has any redundant information or not. Then it removes the redundant information and the rest of the document goes into the T5 tokenizer. Then it encode and decode the summary, text summary with padding, truncation, and attention marks. Then it moves to the text input IDS and flatten text encoding. Then it goes to the T5 base model with AdamW optimizer. And after training and validation, it generates our desired summary. These T5 models hyperparameter configuration setting are chosen with the compute power and resource available in time. As a result, we use manual setup technique to choose the hyper setting. Using a sample function of Pandas framework, the set of data is split into training and testing. The sample in a proportion of 70% and 30% respectively. And in the training base size was 2 and valid base size was 2 and the epoch size was 3. Using this parameter, we have obtained our best result. Here another model we have tried is TextSense and Pegasus pretend model. As Pegasus cannot handle more than 8 sentences, so we have used TextSense to select 8 high rank sentences, and after that it goes to the Pegasus pretend model and to give out our desired summary. We executed an update summarization study on TAC 2009 dataset using a T5 transformer model and TextSense plus Pegasus model. Among these models, T5 transformer model performed the best. It produced high quality abstractive summaries and that effectively captured key information while retaining coherence. Here we can see Rouge 112L score of T5 transformer and Texan plus Pegasus model. The Rouge 1 score of T5 model is 0.027. Rouge 2 score is 0.055. Rouge 1 is 0.251, and the Texan Pegasus value is 0.226 and 0.039 and 0.190 respectively, by which we can say that T5 transformer is being ahead from the other model. We have faced challenges in maintaining coherence and generating longer summaries. Both model has its own criteria and none of them can generate longer than 10 sentence summaries. In the future, we will try to customize the model more so that we come with a solution to this problem. Both models are built for generating abstractive summaries. For that reason, they aren't good as generating extractive summaries. And also in the future, we'll try to explore some hybrid approach that combine both extractive and abstractive technique. In the very end, if we summarize the whole presentation, we can see that we have tried two types of model on TAG 2009 dataset. Our model generated summary retain relevance and concurrency while including no superfluous information. Our research may be small, but it will encourage more researchers to contribute more in this field. Here is the reference part. We have used these references while making our presentation. Thank you all. That's from us.
Thanks for your presentation. Dear participants, do you have any question about this presentation? Okay, no questions. Thank you again. I wish you success in your career. Dear Pankaj Goswami,
Pankaj
are you
Goswami.
ready?
I'm available. I'm available.
Okay.
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 Yeah.
You can share your screen and then start.
Please, I'm sharing.
the presentation.
Is it visible?
Yes.
Thank you so much. There was some network glitch at my place, so because of that, I have to maintain a certain arrangement. Thank you for being patient. So I'm Dr. Pankaj Kumar Goswami. Here is going to present a research contribution related to the ML-based anomalies detection in the wireless network link layer of the Internet of Things IoTs. So that's definitely it's a very, very great in the vast areas nowadays, the Internet of Things. Everyone knows about that. Now everything is going to be connected with the Internet. And this is exactly the IoT.
Sorry, can you enlarge your screen? Can you enlarge your screen? Zoom in your screen.
Yeah. Is it okay now?
Okay.
Yeah. So, well, this is the completely based on anomalies detection in the IoTs. So we understand that now everything and anything is going to be connected on IoTs. So this is exactly the need of today to understand what are the challenges and the issues can be there related with the IoTs. Among them, the one of the great is there. So we have a different kind of a layers in the IoT systems, and under these IoT layers and the connectivities, we have a different kind of issues. And the intruders are there. So anomalies detection is one of the most important area on which the researchers are working and doing their work. So we have a certain kind of a contents. I'm not just taking a brief. So coming up on a 1.1. So let's go for a basic abstract, what kind of work I have done. So basically, let's introduce with the things that if we are suppose working in IoTs, the IoT is basically based on a different kind of a layer of functioning on that. The physical layer is working, the network layer is working, the transport layer is working, the link layer is working, and at different layers. If the IoT is just only for the purpose of the application of the things, then it's okay. But if it is somewhat related with a kind of a security system, which is being included in some sort of the financial transaction, at that time, it is very much important to really work with the security arrangements to find out the anomalies detection. So in the various things, if you see here, the Internet of Things, the most emerging technology expanding the interconnected devices network. IoTs are not covering the commercial utility, but also providing the emergency benefit to the healthcare centers as well. The most recent research activity deals with the anomaly detections in the IoT over the via IoT networks. The automatic malfunctioning over the network is the most tedious task for the researcher. Please just take care of this. This is absolutely a very, very tedious task to identify, because nowadays, if you see here, we are using a mobile phone for the Google payments and looking for the Paytms and anything else. So it is very easy to scan with the help of a scanner and a camera, and immediately an account from your account, a transaction has been done. So if you see this process requires a lot of security features and kind of a thing to find out if some sort of anomaly is coming that has to be detected properly. So if you see here, in the upcoming time, the thing is related with the anything and the everything. Anything and everything will be connected with the internet. And especially we are looking for all those kind of things which requires a certain security. So researchers oriented advancement has undergone for the development and deployment of the new attributes in the IoT system. Agriculture, medical emergency, transportation, security utilities are the basically needs of this. The IT infrastructure is basically a building block, operational architecture in any of the utility, including business model. The increasing number of the sensors and the devices in the wireless sensor networks open the doors or challenge of the reliability of the IoT network. So if you see here, this particular diagram will indicate you that what exactly the IoT system, it is basically covering the application layer, transport layer, network internet layer, and the link layer. So if we see here, the application layer has their own challenges and the transport layer has its one. Network is definitely a kind of issue for maintaining, and most important, which is a virtual layer, which is being connected every time it is a link layer. Just taking an example of this link layer, if suppose you are doing some sort of a payment through your Paytm or using a Google Pay or anything else, any kind of a UPI app is you're doing, so immediately you are setting up a kind of a link is there. So at that time, there's a great chance of the intruders to get into, and definitely a kind of a things will be appeared. So if during such kind of a transaction appears within your account, then it is important to identify whether it is a kind of a regular practice or the natural practices, or some anomalies are already there. So anomalies, if you see, just a minute, if you see here, I'm sorry, showing it back. Yeah. So if you see here, that's the most important IoT reliability. So the most important part is that what kind of a security features are there, what kind of a risk analysis there. So this survey, this research contribution is basically finding out and analyzing all kind of a security risk related with the IoTs. So taking up that, like having a security risk, having a reliability risk, having a layer link risk, and IoT attributes are there. So if you see this particular tabular chart, it will help you to understand what kind of a risk are there and how much they are. So security risks are too high, reliability issues are also there. And these issues are available at the different layers, like physical, virtual physical, and the virtual physical layer as well. And what kind of a things which is directly related with the attribute of the IoT system, it's a smart sensor aggregator, transport, user interface, and the trigger controls are the things. So like what kind of a steps we're doing. So first of all, we are looking to analyzing all kinds of things related to security challenges in the anomaly detection of IoT system. So looking forward, identifying basically a kind of a problem. See, if just taking an example on this particular slide, suppose that you have a certain kind of a transaction every day from your credit card or as well as your from your debit card, and you have a certain kind of a pattern to use in a month to use a 10K and approximately more than 10-20, you have a certain kind of a pattern to withdrawing or doing some sort of a purchasing through your credit or the debit card. And if you see, and suddenly you find that a kind of a purchase or the kind of a debit or the credit has been happened within your credit card account or the debit card account that has a tenfold certain kind of a jump, then it is being called as an anomaly. And that anomaly has to be detected naturally, so that if certain kind of a thing appears, so that should be informed properly to the end user, who's going to definitely get the benefit of loss of from it. So at that stage, it is required to analyze specifically if we are looking for a certain kind of a link layer, what kind of a pattern is to be there. And first of all, finding out the different kind of a pattern and then identifying for a period of a time, for a period of a month, for period of a days, for period of years, what kind of a patterns are being there. If suppose the pattern is unusual and certain kind of a differences are there, then on the basis of those patterns, the anomalies are basically identified. So that is basically the process to identify and analyzing first. So analysis is a very first step to do it. And based on a different kind of analytics, a different kind of literature surveys has been done. And if you see here to identifying all kinds of disciplines, so what kind of a detection schemes are already available. So if we go for identification and classification of anomalies in the link layer of the IoT devices using the SVM machine. So support vector machine is already working in this direction, and finally it is giving the automatic detection. So there's no person, if suppose you are doing some certain kind of a transaction, you are doing a purchase, you are doing for online shopping, because if the internet is there, then definitely devices are being connected and devices are setting up their virtual link immediately based on the requirement. Suppose that it might be possible your mobile phone is connected immediately with some kind of a healthcare services, it may be related with the transport services, it may be related to some educational website. So that kind of a links may be different, and those peoples are working as in a direction to intrude in all these to find out their own personal benefits for that. So that has to be identified in this. So there should be some sort of a mechanism. This mechanism should work in a way that if certain kind of a pattern is found unusual, that has to be detected. So this is basically a kind of an there, and comprehensive review on the various anomaly detection is done, and the challenges has been identified. Is similarly not only support vector machine, various supervised, unsupervised, and reinforcement learning are continuously working on that. So on the basis of that, all kind of a typical literature review and identifying the different kind of analytics and the requirement of that, basically the conclusion has been made. And the conclusion which is coming up, the basic requirement, the kind of a gap is there, over which the researchers and the contributor has to work on that. The task is auto detection is basically a basic challenge in anomalies in the traffic, find its reliability and the feasibility. And not only the detection, but also as well as the action is also important. Challenges is choose the aggregate statistics and input attribute to innovate anomalies detection model. Extensive study and analytics of the possible attacks are challenging issues. So we have a different kind of a model has been created, and this model is basically giving an anomaly detection flow. So we have a certain kind of a network traffic. So we are doing it first as a processing, input processing of it. Then we are applying a different kind of anomaly detection algorithm. See, the anomaly detection algorithm is totally dependent on the kind of a strength and the bulk of a data points. So it may be depending upon the data point, it may be depending upon contextual, it may be different kind of aspects depending upon this. So output post-processing is there, and then finally threat is being detected. So once the threat is being detected, then the second step will come the detection and the finally creating a certain kind of a remedy of it. So a tentative process flow is also there. So we are giving an input, data pre-processing, and this is the whole just in a flowchart form of the previous one. And this is again doing the same kind of and using a different kind of a classifier model. The classifier model is putting the different kind of a patterns identified on the link layer. If suppose a link is being set up and different kind of a link response and acknowledgement is being generated, all those links are identified and putting into the different classification section. So if all these classification sections are already pre-known and predetermined, then only it is definitely considered as a normal pattern and normal pattern of the user. Otherwise, it is to be considered as what I say, this is anomaly. So basically, what kind of outcome is coming up? So real world issue in the operational IoT network based on the public available data set on the anomaly detection model can be developed, which is being developed. Model learning training throughput will record it based on ML algorithm. Comparative outcome of the ML supervised and unsupervised technique. And finally, the categorical anomalies detection may be done. So here we have a final conclusion of this. So in this work, studies focus on the review of the detection of, it means the first step is basically identifying, because it is more important to identify what kind of anomalies may be there. So until and unless the anomalies may be identified, definitely the different kind of algorithm may not be an important part. The analysis conclusions to predict future hazards of IoT wireless network layers. Design and implementation of the different kind of ML, and as well as the putting a different kind of ML combinations and at the different stage depending upon the data set and its solve values. And the most important part is the basically categorical classification and analytical implementation of the machine learning technique on there. So basically, this is from my side. If any question is there, so Please. Please, if any question is there.
Thanks for your presentation. Dear person, do you have any question about this presentation? Okay, no questions. Thank you again, dear Garima Goswami.
This is Pankaj Kumar Goswami. Actually, there was some issue, so I have to log in from the different account. This is Pankaj Kumar Goswami. Okay.
Okay.
Yeah.
Okay.
I have done it. Okay.
Okay.
Okay. Thank you.
Thank you. I wish success in your career.
Thank you. Thank you so much.
Dear Sanaullah Somro, are you ready to present? Dear Sanaullah.
Am I audible?
Okay. You have 10 minutes, please.
Yeah, sure.
You can start your presentation.
Hello, everyone. Hi, this is Sanaullah. I'm going to present you the topic effects of dropout layers inside and long short-term memory for household load forecast application. Since these are my contents which I'm going to present. Since every topic has a reason and my topic reason is about the energy crisis, it had been predicted that in future we will face a lot of problem regarding power. So this topic will cover how we can manage our daily usages of energy consumptions. I have used artificial intelligence techniques to make a model for household load forecast applications. Since machine learning basically works in 3 ways, starting with using a combination of data and algorithm to predict patterns and classify data sets, an error function that helps to evaluate the accuracy, and then optimization process to fit the data points into model which is best for the model, such as self-driving car, image recognition. In machine learning, workflow starts with relevant features using manually extracted data from images. The features are then used to create a model that categorizes the object in the image. With deep learning workflow, relevant features are automatically extracted from the images. This is the neural network, how neural network work with input layer, hidden layer, and output layer. This is composed of nodes of layer containing an input, output, and hidden layer. Each artificial node connects to another one and has an associated weight and threshold. This is the RNN model that I have used to predict the future energy consumption of a household. The RNN contains the inputs and outputs in an standard neural network that are independent of each other. However, in some circumstances, when predicting the next word of phrase, the prior words are necessary, so words must be remembered. As a result, RNN was created, which used a hidden layer to overcome the problem. The most important component of RNN is the hidden state, which remember specific information about the sequences. And this is a data set I had used. This contains 4 years of energy consumptions of single house, which contains different features, including global active power, reactive power, global intensity, voltage, submetering 1, 2, and 3. These graphs show us the nature of the consumer, how he is using electricity according to the weeks, according to the months, and according to the years. This is the graph I found energy consumption per week, per month, and for 4 years. Time series data works on the steps, how much step you want to move. This contains 2 types, single step forecasting and multi-step forecasting. in single step, you can only move to one step, but in multi-step forecasting, you can move a lot of next time steps. This is the model I have generated using the machine learning. And as we can see, our predicted results are much accurate than the actual values are almost accurate. And this is the error I have found, that why my results are not equal to the actual values. And I have subject the actual and real predicted values, and I found this percentage of the graph, in which we can see that at what step my values are not equal to actual values. Dropout is a technique where randomly selected neurons are ignored using training. Their activation of downstream neurons is temporarily removed on forward pass, and any weight updates that are not applied to the neurons or backward pass. As we can see inside the figure, this is the standard network, and this is how we applied the dropout to drop some of the neurons to increase the accuracy. In my scenario, I have used different percentage of the dropouts, as we can found that the actual and predicted values, and these are the differences at different percentage of the dropouts. This is the model loss of the different percentage of the dropouts at one single model of RNN, 0.2, 30%, 40%, 50%, and 60%. We can compare our results by using the MSE. As we can see, without dropout, it was 0.521, but with dropouts, it become closer to the accuracy. And at 0.4, we can see that it's much better than without using dropout. And thank you for your attention.
Thanks for your presentation. Dear participants, do you have any question about this paper? Okay, no questions. Thank you again. I wish you success, dear Sanaullah, in your career. Yes, dear Sanjeda Sarah Jennifer.
Yes, I'm here.
Are you ready to present?
Yes, I'm ready. Just let me share my
Okay,
screen.
you can start your presentation. Okay,
So, is my screen visible?
yes. You have 10 minutes, please.
Okay. So greetings, everyone. Thank you for giving me the opportunity to present my paper on the 5th International Congress on Human-Computer Interaction and Optimizing Robotics Application. The title of our paper is BalinBot, a bilingual chatbot using deep learning. And the authors of our papers are Sanjida Sarah Jennifer, which is me, Sheikh Aminul Islam, Sharmin Sultana Kohli, Rashidul Amin Tuhin, and Saddam Hussain Khan, and MD Mohsinuddin, and we are from East West University, Dhaka, Bangladesh. So as we can already guess from the title that we created a bilingual chatbot and named it BalinBot. We already know that a chatbot is an AI-powered conversational agent designed to interact with users, provide automated feedbacks and responses. Eliza was the first intelligent conversational agent which was created, the first chatterbot which was capable of attempting the Turing test. So when I say bilingual chatbot, it simply means that a conversational agent which is able to interact in more than one language. As we can see on the screen, the simple English word hello can be translated as marhaba in Arabic and namaste in Hindi. Similarly, for our work, we intend to create a chatbot which can converse in both the Bangla and the English language. So as we can see on the screen, we tested out some bots, but the output was not what we expected. When the same word, basically we know that football and soccer are the same thing, but when it was replaced with soccer, the bot could not answer properly. And when the same question was asked, keeping the football part same, but just rearranging or paraphrasing the sentence, it again could not answer. So this is the reason why we incorporated these chatbots, because from the perspective of our country, these usable bots are in demand. The educated society, those who know how to prompt engineer, are the ones who are benefited the most from the recent advancement of technology, but people of all the classes are not on the same level to utilize this. Therefore, the necessity of a simple bilingual chatbot is unavoidable. So we proposed BillionBot, and we trained our model using the paraphrase data for them to understand the different forms of the questions so that it can answer in accordance to that. Now let's look at our contribution, the challenges that we faced, and our preparation. Preparing the dataset was one of the most important tasks for our research. English datasets are readily available as English is the first and the most spoken language, but when it comes to Bangla, it's extremely difficult. Therefore, we processed the English dataset first, filtered all the unnecessary punctuations, converted them to lower cases, fixed the spellings, grammatical errors that were there, paraphrased them to find all the possible forms and ways of asking something, generated token, created vocabulary, and padded the sequences. We analyzed the best deep learning methods and the feature engineering approaches, and finally performed a comparative analysis. So this was for the English dataset. And in order to create the Bangla dataset, we translated our English dataset to Bangla and followed the same procedure. Here's just a simple snippet of our raw dataset for both the Bangla and the English language. The methodology was quite simple, as after taking the user input, it will be tokenized, followed by a path sequence, and predict the output of the response using the trained model. The implementation is also similar, which is pre-processing the dataset at first, feature engineering, training the model, and finally testing our model. To find the best feature engineering approach, we used word-to-vector, BERT, and TF-IDF tokenizer, and we have found that Google BERT has the best feature engineering approach for our chatbot, considering that it had an F1 score of 0.96 while the others didn't. Now, as for the deep learning methods, we have used recurrent neural network, long short-term memory, and gated recurrent unit for training, and we found that LSTM and GRU were the best deep learning methods for training the chatbot, as we can see that the average epoch training accuracy was 97% for LSTM and 99% for GRU. We have also tuned the hyperparameters to reach the optimum result and tested the system with different optimizers like SGD, MSProp, AdamX, and Adam, and found that Adam had the maximum output when it was used as an optimizer. Now, for evaluating our model, we performed Rouge 1, Rouge 2, and Rouge L evaluation on the original and the predicted response. Here are the test questions with their respective predicted answers. The precision recall and F1 score were all 0.96. As for the Bangla dataset, it was 0.76. For example, on the fourth question, we can see it's written in Bangla that Tomar agrohogula ki ki. It answered Ami shob dhoroner bishoye agrohi. Amra je kono bishoye kotha bolte pari, which literally translates to what are your interests? And the answers that we received were, quoting, we are interested in everything, we can talk about anything. Just to remind you that the trained model, the model that we trained the dataset on, was created by us, which was translated from the English to Bangla language. Now let's look at the comparative analysis with the state-of-art work. We took conversational AI chatbot and the sequence-to-sequence AI chatbot. The conversational AI chatbot implemented the encoder-decoder attention mechanism architecture using 2 RNN and with LSTM cells. The encoder takes a sequence as input and processes one symbol at each time step. The decoder is influenced by the thought vector and generates another sequence, one symbol at a time. They have introduced the attention mechanism neural machine translation, which allows the decoder to selectively look at the input sequence while decoding. On the other hand, the sequence-to-sequence AI did the same thing, but they proposed to use CNN instead of RNN as an encoder. LSTM was used for the decoder enhancement technique. Similar to conversational AI and sequence-to-sequence AI, our chatbot, which is BillionBot, also used deep learning, but it did not involve the encoder-decoder mechanism completely, but That mechanism was not used for our chatbot. For natural language processing, we used BERT, word-to-vector, and other feature engineering approaches. We proposed a solution that enables our chatbot to understand the different forms of a sentence, but their bot didn't have that ability. For the learning, we used deep learning approaches like LSTM and GRU. We have used our dataset to train their chatbot to perform the comparative analysis. We used 100 test data of our chatbot and used theirs to see the result in English dataset. Those test data were paraphrased but were not used in the training process. As we can see, some of the tests, we tested the questions with all the 3 bots. Our chatbot understands different paraphrased form of the sentence, while the other 2 chatbots do not understand the paraphrased forms. For example, when it was asked, when are you going to work? BerlinBot answered, as soon as I get enough money for my robot body. Whereas conversational AI responded, I am sorry, I do not understand. And Sequence AI said, sorry, I don't understand your context. So, in conclusion, we analyzed the best feature engineering approaches, the deep learning methods to create BerlinBot, which understands different ways of answering the questions and is able to answer even if they are asked in the different form or different structure. It can be used for many purposes, especially for small-scale businesses whose target audiences needs Bangla and those who prefer to keep their options open for their businesses as well. As for the future work, in the future, we plan to include other languages as well and create a multilingual chatbot from this bilingual chatbot and train it on a broader set of data so that it can perform even better. So here are the references that I've used for creating this presentation slide. And this is the end of my presentation. Thank you so much, everyone, for your time.
Thanks for your presentation. Dear participant, do you have any question? Okay, no questions. Thank you again. I wish you success.
Thank you.
Dear Uğur Yıldıran.
I'm here.
Okay, if you are ready, you can start your presentation.
I'm ready. Can you see the screen?
Yes, you have 10 minutes, please.
Okay, I'm Dr. Uğur Yıldıran from Yıldız Technical University. Thank you for listening. I will present my work on dynamic programming versus Q-learning for feedback motion planning of manipulators. So this is the content. I will start with the motion planning problem. Then I will give a brief literature review about this problem. Then I will give a motivation about this work, and I will give MDP formulation of motion planning problem. And I will continue with the 2 approaches that I'm going to use in this work, which are value iteration and Q-learning for motion planning. Lastly, I will present results and I will finish with conclusions. So firstly, motion planning problem. In this problem, we have a robot, and in this case, it's a manipulator. And we define the configuration of the manipulator as a vector of joint angles theta. And the configuration space is the set of configurations for which the manipulator is not in collision with the obstacles. And the goal of the motion planning problem is to move the robot from a start configuration theta 0 to the goal configuration theta g without colliding with obstacles. There are several methods proposed for the solution of this problem. One group of methods are classical methods for motion planning. Examples of them are cell decomposition, visibility graphs, and skeletons. These methods are complete. That means that they are guaranteed to find a motion plan after finding the amount of time. But there are some issues with these methods. Firstly, they require a mathematical model of the problem, but usually when you have a complex system, you only have a CAD model in simulation instead of a mathematical model. And secondly, they are applicable to small problems in practice because as the problem size increases, the computation times increases exponentially. And that's why in practice, they are not really applicable to complex problems. And due to these issues related with the classical methods, later on, researchers introduced a different kind of approach, which is called sampling-based methods for motion planning. There are lots of proposals, but 2 important ones are rapidly exploring random trees and probabilistic roadmap methods. In both of them, the algorithm is generating random samples or sampling random points on the space and trying to connect them with collision-free line segments. In RRT, what's constructed is a tree, but in PRM, what's constructed is a graph. So they found to be effective in finding motion plans, but they only give probabilistic guarantees, means that they are guaranteed to find a trajectory with probability 1 as the number of samples goes to infinity. But there's still some problem with this approach. The motion plans generated are open loop. That means they just provide a trajectory and you follow this trajectory. But if you come across with some uncertainties, this trajectory will not be valid anymore. And if you follow it, you can collide with obstacles. And to avoid these problems, an alternative is to create feedback motion plans, which means that you need to create or compute a feedback controller, which continuously observes the states of the system, and depending on the current states, it decides on the action to approach, the action to apply. And there are different methods that can be used for this purpose, but one of the recent popular methods is using reinforcement learning approaches. In reinforcement learning, we have an agent interacting with the environment, and the goal here is to learn a feedback policy, which is a controller, which maps the states to the actions to be taken. And also it computes another thing which is called the Q function, which evaluates the value of the current state when you take a specific action. So a good thing about reinforcement learning, as I said, it gives us a feedback policy. So that's why the plan that's found will be immune to uncertainties, because if you somehow go to a different state due to an uncertainty, you can directly read a new action to apply, and you can, for example, avoid colliding obstacles. But the thing is this, when you look at the reinforcement learning approaches, they are usually working slow. And that's why they are not really practical to use at the beginning in a real experimental setup. Usually we train them on a simulation setup because you need to perform several epochs for training. And also if you train the agent in the real environment, then it can damage the system. So we usually do this training, that's why in the simulation environment. And another feature of the reinforcement learning approaches like Q-learning is they somehow learn by interacting with the environment, applying physical implementable actions. But in the simulation environment, you don't have to implement or apply physical implementable actions. You can actually make unrealistic moves. And when you think of the Q-learning, for example, it makes use of the Q function, whose dimensionality depends on the number of states and the number of actions. And this can cause some problems due to curse of dimensionality. But instead of using the reinforcement learning techniques like Q-learning, if we use dynamic programming techniques like value iteration, then we can get rid of these extra dimensionality coming from the action space. And that's why instead of using a Q function, we can use a value function, which will have a smaller dimension. And that's why it will be affected less from this curse of dimensionality. And secondly, since as I said before, in the simulation environment, you can perform unrealistic actions. You can use value iteration approach, because in the value iteration approach, the algorithm requires the agent to jump from one state to another state and freeze the time and apply different actions. So these are not realistic moves, and that's why you cannot apply them in a real setup. But since we are in a simulation, we can do them. And that's why instead of using reinforcement learning, we may try to use dynamic programming approaches like value iteration in order to make training faster and more effective. So this is the main motivation behind this paper. So when we look at the literature, most of the people are training their agents or manipulators or robots in the simulation environment using Q-learning. But instead of this, if we use value iteration, the learning can be faster and more effective. And I will continue with the formulation, mathematical formulation of the motion planning problem. So we will use MDP formulation. So we will discretize the problem in space and action, in state and action spaces. So we can define an MDP as a tuple composed of a set S and action set A and transition function P and reward function R. Here we are discretizing the state stat using delta increments, as you can see on the lower left corner of the figure or of the screen. So we are discretizing the space, and we are considering only three actions: minus delta, 0, and delta. Here delta is discretization step that we use in our state space. And the state transition is simply current state plus the action that we are applying, and we are also saturating it, because if we come to the upper limit of the joint angle, then we have to stop there, and that's why we have a saturation function in the transition function. And lastly, in our reward function, if the agent collides with an obstacle, we give it a high cost or very low reward, -100, in order to prevent collisions. And we want agent to reach the goal as fast as possible, and that's why, as long as the agent doesn't reach the goal, we give a reward of -1. So we want it to finish as quick as possible. And if the agent reaches the goal, then the reward is 0, because we achieved our target. And we can define the infinite horizon value function associated with this problem as above, as you can see in the first formula. So summation of rewards over infinite time, subject to the system dynamics. And the Q function can be defined using the value function. So Q function is the total reward that we obtain given the current state after applying the action AT. So we can compute it using value function V and also the current reward R. In the value iteration algorithm, we make use of Bellman's dynamic programming equation in order to compute the optimal value function. You can see the algorithm there. It starts with initializing the value function matrix. And as long as the change in the norm of the value function matrix is greater than a threshold epsilon, we continue. And each time we are using the Bellman's equation in order to compute the best action that we have right now and compute and also improve the value function matrix. And the other approach that I will compare with is Q-learning, and you can see the algorithm of the Q-learning. So again, this time we are using a Q function matrix, and as long as the change in the norm of the Q function matrix greater than the threshold, the algorithm continues. We choose a random initial state, and we then get into a loop where we generate a trajectory by following an epsilon greedy action, and we use again Q-learning update formula in order to update the Q function. And let's have a look at the results. You can see the environment that we are using on the left. So we have a manipulator and there are some boxes, and the goal is to bring an object to the top of the brown box. So this object can be on one of these green boxes, or it can be somewhere else. Since we are computing a feedback policy, it can be anywhere. So feedback policy will tell us how to go to the final position, which is the top of the brown box, from any position that we want. And we use the WebOds as the simulation environment. And on the right, you can see the parameters that we use, the limits of the joint angles, and also discretization step increments. And let's have a look at the results. Firstly, I compare the convergence properties of these two algorithms. On the left, you can see the change in the norm of the value function matrix. And as you can see, it converges after like 40 iterations. And it took like 2,662 seconds to complete. And on the right, you can see the Q-learning convergence graph. Here I'm showing the average change over 50 iterations or 50 epochs. And as you can see, it goes down, but even after 80,000 epochs, it didn't converge quite well. Actually, it's not really meaningful to compare the epoch, number of key epoch, with the number of iterations here, because they are different things. They are like apples and fishes, and that's why we shouldn't be comparing them. But what I did, I ran both algorithms the same amount of time, 2,662 seconds. And after 2,662 seconds, value iteration converged completely, but the Q-learning still didn't converge. As you can see, there are ripples, and actually the change is significantly larger than the threshold that we have. And we can see also the simulation results. These are the joint angles of the manipulator. So manipulator is a 3 degree of freedom manipulator, and that's why there are 3 joint angles. And as you can see from left and right, for both of the algorithms, the robot is reaching to the target. But as you can see, value iterations trajectories are smooth and nice. But if you look at the trajectories generated by the Q-learning algorithm, as you can see, they are jagged. Okay, there are some ripples and they are not optimal. And the reason is Q-learn couldn't converge after same amount of time. So basically, conclusions. The goal of this study was to use the value iteration method for motion planning of manipulators and compare it with the Q-learning method, because Q-learning is used frequently in the literature in the simulation in order to train the agents. But the claim of this work is this: Q-learning is not really the good method to choose. Value iteration performs better. And the main reasons are the dimensionality of the value function is smaller, and also value iteration approach doesn't require exploration, unlike the Q-learning approach. And if you're in the simulation, you can perform unrealistic moves. It's not a problem. So that's why you don't have to use a reinforcement learning algorithm. And in the results, we saw that value iteration converged much more faster, and the trajectory generated by the value iteration algorithm were smoother and optimal when you compare with the Q-learning. So as a result of this study, I would suggest to use value iteration instead of Q-learning in a simulation environment for training agents. And that's all. Thank you for listening. Is there any question?
Thanks for your presentation. Dear participants, do you have any question? Okay, no question. Thank you again. I wish you success, dear Uğur Yıldıran.
Thank you.
Shirin El Ofari.
Yeah, I'm here.
Okay, are you present?
Yeah.
Okay, you can start your presentation.
Yes.
You have 10 minutes, please.
Yes, thanks. Hello, everyone. I am Shirin Al Ufari, master student in Yildiz Technical University. My presentation about classification of PCA-based reduced deep features by SVM for diagnosing lung and colon cancer. This slide, my presentation consists of 8 content as shown in this slide. Lung and colon cancers are one of the most known cancer types that cause death. Of course, early detection of the disease has a critical impact in limiting the spread of tumor cells. Artificial intelligence has been added to the field of medicine to improve the clinical decision-making process. The interaction between medicine and humans gives the best quality in less time and cost to reach the correct diagnosis. The dataset used in this work was ALSI 25,000 dataset obtained from the Kaggle website. This dataset consists of 5 classes. In colon, there are 2 classes, adipocytomas and benign, and in lung 3 classes, adenocarcinomas, benign, and squamous cell carcinomas. This dataset already augmented to 25,000 with 5,000 for each class. This samples image of dataset. Introduction to transfer learning. This figure shows basic architecture for CNN. There are 3 types of layers that make up the CNN, which are the convolutional layer, pooling layer, fully connected layer. When these layers are stacked, a CNN architecture will be formed. A convolutional layer extract the various feature from input image and pass result to the next layer, which is pooling layer. Pooling layer decrease the size of the convolutional convolved feature, and the fully connected layer, which contain the weight used to connect neurons between two different layers, and the output, which is the prediction. CNN is a fully connected neural networks proceed by a feed-forward network structure of numerous layers of convolutional filters that are alternated with subsampling filters. The concept of transfer learning, previously trained CNNs are utilized in a new domain by transferring and allocating the previously acquired feature. Instead of training the model from scratch, pre-trained weights used as a starting point of the network minimize the training time of a model. In this work, support vector machine was applied, which is one of the supervised machine learning algorithms, gives good results in the field of image classification within a more short time and than other complex techniques. SVM depends on finding the best decision line or boundary. This limit or the best boundary or the best region is called the support level, focused on finding the closest point to the dividing line for all categories. Excellence technique for both linear and nonlinear relations modeling. In this work, linear kernel was used. Also, in this work, a principal components analysis PCA was applied to reduce the dimensionality of features by creating a new features containing most of the original data variants by extract features from data by combining with each other. PCA significantly reduced the dimensions of the space without changing the number of samples. It used all of the original variables to generate new latent variables, principal components. This slide shows the methodology applied in this work. The dataset organized for a 5-cross validation structure. There are 3 scenarios were followed to classify a group of colon and lung cancer images. AlexNet, SqueezeNet, and ShuffleNet were considered as the CNNs. CNNs were utilized as a classifier for lung and colon cancer images. The classification performance of each model was quoted as softmax performance individually. Only the feature extracted from the image by the pre-trained model were collected and fed to SVM. A PCA were applied over the extracted features of the networks to reduce the number of features. After the feature selection process, the reduced features sets were also fed to SVM to raise the classification accuracy. This slide shows the results obtained from this work. In all network, the best result in third scenario when applied PCA and SVM, and the best results in ShuffleNet, which obtained 97.92%. Also, this in lung results. Also, in colon results, the best results obtained for all network in the third scenario when applied PCI and SVM, and the best result in ShuffleNet, which obtained 99.93%. The conclusion: cancer is generally considered among the deadliest disease in people's lives. Colon and lung cancers constitute a high percentage of the most dangerous cancers. Early detection of these tumors plays a critical role in the treatment of disease. The implementation of artificial intelligence in medicine to classify medical images provides satisfactory results in analysis and eliminates the exhaustive time consuming process to determine a machine learning-based analyzing approach to obtain the best and most accurate results. ElixNet, SqueezeNet, and ShuffleNet applied in this work. All models were evaluated as classifiers by using softmax layers in the classification steps. CNN were used as feature extractors to feed nonlinear classifier SVM and feature selection technique. PCA were applied to the extracted feature to eliminate informative feature. The PCA over the CNN's features to feed SVM resulted in give the highest accuracies for both datasets. Thank you, everyone. Any question? I'm ready.
Thanks for your presentation. Dear participants, do you have any question?
Hi, Miss Rain.
Okay.
Okay, I have one question because I'm quite interested with your presentation just now. Just I want to ask, as you have achieved some kind of recognition accuracies based on the lung detection, and also another one is the lung, and another one is what just now?
Sorry, I don't understand.
You are doing the classification for the lung cancer detection, and another one is what just now?
Yes, lung cancer and colon cancer.
Yes, colon cancer. Okay, so as you have already achieved those kind of recognition accuracies, what is the expecting contribution? Because this one is for your master studies, right? What the expecting contribution that you may focus on those algorithms that you have test all the algorithms. So what is your expectation of contribution on the area?
I don't understand.
Okay, shall I write, because this is interesting topic. Just I want to know what is your expected contribution. Your expected contribution based on the algorithm that you have been chosen through your experiment just now.
I choose the SVM because it's given me a good result. I applied this work by Python.
Yes, using the Python.
Yeah, I use Python.
So for the CNN, you use it as a part of feature extraction, is it?
Yeah. I used these three CNNs to extract just to extract the feature.
Okay. So based on your study, did you get any kind of comparison with other researchers that maybe they are already focusing on those algorithms that you have been testing?
Yeah, of course.
Okay. So that's all my question. Thank you, Ms. Sirin.
Thank you. Thanks.
Okay. Another question. Do you have? Okay, no question. Thank you again. I wish you success, dear Shirin El-Fahri.
Thank you.
Next paper belongs to dear Swash Sami Mohammed.
Hello.
Hello.
Do you hear me? Okay,
Yes.
I am Sawash. Okay, I am ready to make my presentation.
You can start your presentation if you are ready.
Thank you. I'm sharing my screen.
Okay. You have 10 minutes, please.
Thank you. Okay, my name is Sawash, and I'm a PhD student at Electric and Electronic Engineering at 19 Mayıs University in Samsun, Turkey. Our work is about improved malaria cell detection using deep convolutional neural network. The outline of this work or this presentation will be just as follows. We'll talk about identifying malaria cells, related works, data set, and used methodology. After that, we will talk about training. Can I hide this one? How should I hide this one? Okay, what is malaria? Malaria is a life-threatening disease spread to human by some type of mosquitoes. It is mostly found in tropical countries, a dangerous disease, but also it can be prevented and cured if an early detection of this infection is detected in early stage. The infection is caused by a parasite and does not spread from one person to another. Okay, this research represents a deep convolutional neural network as a solution for identifying malarial cells that are infected. The proposed artificial neural network model suggests in this work consists of 3 layers, layered convolutional neural network and 2 layered dense neural network. The model is trained over 2 epochs and evaluated using binary cross entropy, loss function, and accuracy metric to assess its performance. The proposed model achieved an impressive accuracy of 96 and maintained a loss value below 0.2 for both training and validation datasets. Okay, if we look for into related works, previous works, we can see that Olog, Bia, and others in 2017, they are using some methods like linear supported virtual machine, coordinates, SVM, fine, Gaussian support vector machine, and cosine, k-neighbors, and several other methods, and they achieved top maximum accuracy of 86.3 accuracy. They are used 130 images for the from the central of disease control for evaluating the performance of the proposal classified by them. Rajaman also used AlexNet, VGG16, ResNet, Exception, and DenseNet 121, and customized convolutional network, and they achieved maximum 95.9 accuracy percent. We can see here they are used the all available images in this data set, all of the available images. The next one, if I can remove this. Okay, Syria, they have achieved 91.2, but they does not use all the available images. I don't know why they do that. Next, the proposed model. I have some kind of issue right there. Okay, if I can move this. Okay, our proposed model is developed convolutional network. We have achieved 96% of accuracy. We are using all available images in the provided images by datasets by Kaggle. Okay, here is we are talking about the data set. The data set is provided by Kaggle, which we have a total of 27,558 images. we can see from this table we provide here, it is a challenging problem. In these two images, we can see the parasited cells and unaffected cells. These two images, it shows it's simple, even by the human eye, we can identify the parasite cells. But if we look into two other samples, we can see it's harder. If we look into these two cells, it's harder to identify which one is parasited, which one is unaffected. So we present a customized convolutional network for identifying the infected malaria cells. The proposed model takes an input of image which have size of 128 by 128 by 3, which means it's a colorful image. The proposed model consists of 3 convolution layers. The two first convolution layers consist of two-dimensional convolution layers, which with filters of size 3 by 3, and the next one is the next set of convolution filters are with size of 5 by 5. We are trying to capture the smallest features and larger features by changing the filter size. We repeat the same process in the next layer, and in the final layer we are only using small filters with size of 3 by 3. Each convolution layer is filters are followed by radio and max spawning layer with size 2 by 2. The extracted features from the convolutional neural network is flattened out and then fitted to dense neural network in order to make a decision whether the input image is represent an infected or unaffected malaria cell. In training process, we are training the model only for 20 epochs. We are not training the model for more epochs because we are avoiding an overfitting problem. We see that the training model is only for 20 epochs is really enough, and in this situation we are achieving a good results. Our performance is evaluated using an accuracy metric. The parameters of training is as shown in this table. We are showing the learning rate, optimizers, Adam optimizer. We're using binary cross entropy since it's only binary classification problem. Our metric is accuracy. The data set is split out 80% for training, 20% for testing. And the total trainable parameters of our proposed AI model is 278,129. We are using Google Colab platform and Keras library. Okay, after training the model for 20 epochs, we had these results. As we can see, the training and validation loss are going below 0.2 and nearly 0.1, which is considered a very good result. And also our accuracy is achieving over 96 of accuracy. As a conclusion, in this work, we proposed a customized convolutional neural network which captures small and larger features to extract as much information as possible from input images. The proposed model showed an outstanding result with an accuracy of 96% and loss value below 0.2 in both training and validation dataset, while training only for 2 epochs. This result could be improved further by training the model more epoch. However, this could be lead into overfitting problem. Finally, this research can offer promising outcomes when used in automatic malaria disease detection by counting the parasite cells. Thank you very much.
For your presentation, dear participants, do you have any questions about the paper? Okay, no questions. Thank you again. I wish you success in your career.
Thank you. Thank you very much.
The last paper of the session belongs to dear Tuzu Link.
Yes, I'm here.
If you are ready, you can start
Yes.
your presentation.
Yes. Okay. Hello, everyone. My name is Zilin Li, and I will present my study about an algorithm-based approach for mapping customer journeys by identifying customer browsing behavior on e-commerce clean string data. And this is my outline. I will introduce the research background and our research goals. Then I will talk about our methods and results. Finally, is our conclusion. With the advancement of technology, more and more consumers will shop online, and the pandemic also has accelerated the shift towards a more digital world. Clean string data represents granular information on every online touch point consumer purchase. As a result, clean string data is gaining an important role in companies. For e-commerce, understanding consumer intention or motivation is an extensively studied research topic. Lemon and Verhoeven summarize the conceptual background of customer intention as dynamic process and map the customer journey model for customer experience. So customer journey analysis help enterprise understand customer views and apply this model in marketing. This is customer journey model. There are 6 stages of a model. Awareness is built in the early stage of the customer journey and significantly influence the final choice and holistic experience of customers. And then the second step is consideration. The users intend to gather all the relevant information to make decision. Then customer preference in this stage are the likes and dislikes and expectations that influence a customer decision of whether they should purchase a product or service. In purchasing phase, the customer is looking for a transactional landing page focused on the product or service they want. It is characterized by behavior such as ordering and payment. Retention stage aims to build a long relationship with customers. It is valuable for companies because they can earn profits with few costs. Advocacy means customers give great reviews, refer friends or families, and generate the most powerful kind of marketing like word of mouth. And a lot of clean string data is a powerful source of information for consumer behaviors online. However, using clean string data involves some challenges because data is so disorganized that it is not easy to process and analyze. So research is limited. To our best knowledge, none of these exciting studies has focused on the effective using of clean data to identify customer intention with the customer journey model by machine learning. In addition, previous studies about the customer journey model were from the customer's perspective. However, we challenge this framework and use the session as a unit of analysis. The benefit of our approach is it can prevent a situation in which a customer may have different intentions during different periods. And we use an online electronic retailers listing data based on Taiwan. Each of the data contains 9 attributes as follows. Category is an important attribute for this study. Category contains 22 kinds of categories as follows. Different category means customers browsing different kinds of pages. Then I will explain how we do data preprocessing. First, we delete the data which is not the target of this experiment. For example, the list purchasing process needs to browse through the product page, bucket page, purchase page, and thanks page, which is 4 pages. Hence, if this data session ID count is less than 4 pages and the category doesn't contain purchase or thanks, we delete it. Furthermore, we also use a box and whisker plug approach to remove the session ID outlier. Next, we integrated the attributes whose meaning is similar. Therefore, the category thanks is replaced with purchase because customers must not reach the thanks page until they pass through the purchase page. After emergence, the count of categories attribute become 21. In addition, if a session ID's category start with purchase, it means this session ID is highly connected to the length 1. To verify the connection, we check the list session ID which we were merged and found that the product customer purchase was what they browsed during the last session. Finally, we want to explore how customers distribute their time in each browsing session by every category attribute time proportions. So we sum up each category attributes browsing time in every session ID and transpose them into proportion. So the preprocessed data is presented as follows. The horizontal axis represents each category attributes browsing time proportion, and the vertical axis represents every session ID. Then we use clustering model k-means to cluster session data to get optimal number of clustering. We use elbow method. And finally, to define each cluster, we use the decision tree model to analyze the customer and find each cluster's important attributes. Then using elbow method, we determine the count of cluster is 4. And next, this is the decision tree result is for cluster 1. Note that if cluster is 1, it means a certain cluster. So we can get a rule that is category single product is more than 0.455 and multiplied less than or equal 0.437. In addition, we can find for class 1 average value of single product is larger than other clusters. Based on these rules, we think customers already have a shopping list and they are browsing this platform frequently because this platform is their consideration. Then this is for cluster 2. We can get a rule that is category multiplied is larger than 0.356 and single product less than or equal to 0.4549. In addition, the average value of multi-product is larger than other clusters. So we think customers are browsing this platform casually and just start to know about this platform, but don't know what they want to buy. Then for class 3, we can get a rule category single product is less than or equal to 0.448. And mother products is less than or equal to 0.344, and check account is less than or equal to 0.368, and the average value of attributes are smaller than other clusters. But we found a category of bucket, EDM, and search are larger than other clusters. So we think customers may check final bucket and intend to drop an order. And then let's cluster results. We can get the rural category check account is more than 0.385, and single product is less than or equal to 0.478, and multiple product is less or equal to 0.424. The average value of check account is larger than other clusters. So we think customers already have a shopping list and they have consideration for this platform. They are checking their member benefits and comparing products price to other stores. According to the cluster results combined to customer journey model, we will apply them to present marketing suggestion for these 4 stages. Finally, the marketing suggestion will be divided into marketing goals and approach. The awareness stage is mapping for class 2. Customer in this stage casually browse the multiple page on this platform and start to know this platform. So this stage marketing goal is to enhance customers' trust and give them more helpful information to push them into the next stage. To reach this goal, companies can put more information about their company's history, brand spirit, and even customer reviews on their website. This can help the new customer become familiar with this brand and build trust quickly. Then the consideration stage is made for cluster 1. Customers in this stage already have a shopping list, so they browse the single product page on this platform frequently, since the platform is their consideration. Hence, the marketing goal is to make customers know this brand is different from others. Introduce this brand strength through KOL is a viable method to reach the marketing goal. Key opinion leaders play a vital role in marketing communication, and they can provide more consumer related advice to others. The preference stage is made for customer 4. Customers in this stage already have a shopping list and they prefer this platform. In the meantime, they are checking their member benefits and comparing the product's price to other stores. This stage means to give them a thought that purchasing on this platform can save a lot of money to place an order. So we can give customized coupons to satisfy customers' needs as this stage marketing approach. The purchase stage is made for customer 3. Customer in this stage check the final bucket and drop orders. The priority in this stage is to give customer a good after-sales impression. If we reach the goal, customers will move to the final stage and build long-term relationship with the company. So for our study, we use machine learning methods to analyze each browsing behavior session as one unit to overcome the limitation of previous research, which focus on the customer journey by taking one customer or consumer behaviors as one unit. Furthermore, this study mainly focus on the attribute of browsing time in each category to analyze customers' intention. The result to show it is a feasible approach. Based on this priority, this study surprised a new customer browsing intentions analysis mode of integrating theory and practice by clean string data, which can be applied to business. Thank you for your attention.
Thanks for your presentation. Dear participants, do you have any question? Okay, no question. Thank you again. I wish you success in your career. Dear Tuzu Link Lee. Dear participants, thank you for your attending. Thanks for your contribution. I wish all participants continued success. I would like to end this session. Have a good day. Good luck.